Now we're on. Yep. See, I'm making sound.
All right.
That's us live. Hello,
Oh, the
everybody.
camera? Oh, this is with camera.
Yeah. That's great.
This is like an audio thing. Cool.
Oh yeah, we're doing the whole thing, and I'm slowly bringing up Twitch. I really need to get a box that doesn't like go into freak out mode every time.
That's a lot of processing, huh?
And then it's just streaming one channel. The one over there streams. I have like 5 videos that go into it. But we'll watch this and keep tabs on the chat in case anybody wants to chat at us. As always.
Cool.
How do you say your last name?
I'll give it a try. It's incredibly hard. Yeah, exactly. Broecheler.
Broecheler.
Yeah, it's entirely my parents' fault.
Yeah. Well, my parents kept it real simple. It's just Hall.
Hall. Can't get much simpler than that.
Theoretically, a bunch of generations ago, it had a U with a little thing over it, and it was slightly different. But I guess some of my long ago peoples in the family invaded some Anglo-Saxon people somewhere and changed it to Hall because they didn't want to get picked on anymore. Something like that. But
I heard a lot of names change when people get to Ellis Island. So that's
yep.
Like I see a lot of German last names that are pronounced in very weird ways because that's how they read it off.
I think ours did a couple times on the England arrival and the U.S. arrival post facto. But I don't know. It's hard and fuzzy to figure it out. Oh, did someone? Hey, Digital Drummer. Thanks for the sub. I'll tell you Twitch stuff at the same time if you're curious.
Yeah, I have like no idea what this is like a completely new world for me. So you have like people chatting at you at the same time?
This is streaming.
Cool.
This is their chat. A little alert just popped up and said, Digital Drummer, or Justin, just pinged me a sub, which means he's been subscribed to my channel for 6 months now. That's not just a sub, that's 6 months. Damn, thanks, man. That means they actually pay.
Wow,
to
cool.
watch it, yeah, which is really cool. Then there's cheers. So like they can cheer with bits and stuff like that, which is another way to sort of pay. It's like pennies at a time. It's like somebody throwing pennies at you. I always think of bits as like, you know, in the bank, you go to the bank, you get a roll of pennies. I always think of it kind of like that. It makes it more fun in my head. It's like somebody just took one of those and rolled it and
like
chunked it
right
in
your
face.
Like,
oh, cheered.
Sweet.
Okay, yeah, you threw bits at me. But yeah, so there's all that stuff. People chat, and then it's just it's a good time. It's a fun platform to converse on. And then the other stuff I do besides conversations like this is code, and more code. So I do all sorts of infrastructure stuff. Got a thing lined up soon that I'm going to be playing. I'm going to play with AppStax on the stream. So just kind of like go through a bunch of stuff and show people. Playing around with the DataStax desktop thing. Did we just call it desktop?
Desktop, yep.
Everybody keeps saying that. I don't know if that's the actual name of it or not.
I think it is, yeah.
So I'm going to be playing around with that soon. And then I do a bunch of stuff where it's super deep dives. Like I've been putting together a cluster with Terraform. I should say I put together a Kubernetes cluster, but I'm doing Kubernetes cluster with operators for Cassandra and DSE, and then I'm working on just spinning up one with virtual machines. And then at some point, this thing is going back together, or is being put together. So it's going to be a Kubernetes on the metal installation with the database cluster running on operators on top of the Kubernetes on the metal installation. So it's going to be nuts. I got the Bastion server and the 5 boxes, and then 5 boxes sitting in a box somewhere that are going to get added to it. So it should be fun. So yeah, that's a lot of the stuff that I do with the Twitch and all that good stuff.
Nice.
So since no one knows who you are except for a slight pronunciation of your last name.
Exactly. That's all you need to know, really. It's an insanely crazy last name.
Yeah. So, well, tell everybody who you are and some of what you do.
Some of what I do.
Yeah.
So my name is Matthias.
Yeah.
I work at DataStax now as the chief technologist, which basically is a somewhat ill-defined title for working on new products inside the CTO's office, and we just call it that. And so part of that, one of the things I'm working currently on is AppStax. Prior to that, I started a company called Aurelius and built the Titan Graph database, which was then acquired by DataStax. So that's how I ended up at DataStax. So I've been doing lots of graph database work. My PhD was actually in graph databases, and that's where Titan came from. So I've been doing lots of graph database type of work, so working on highly structured, complex relational data, and how to build database systems that can handle that kind of data. And yeah, and then got a lot of experience that way with working with customers and seeing what the actual problems are, and now trying to address what I think is one of the most fundamental problems in database systems with this new thing called AppStax. So that's kind of what I'm currently working on. So yeah, I'm a huge data nerd. I love thinking about like data problems and how we can make all the data available to us in sort of immediate form, so it's immediately actionable. And
cool, very cool. You said data nerd. I feel like I should have my selection of oddball like data nerd T-shirts. I have a really nutty selection of those. I like a bunch of custom ones that New Relic did,
cool,
which were specific to the places they have offices. Like they did one in Portland of the Steel Bridge, which is Portland's 112-year-old steel bridge that has 2 lift points and has heavy rail, light rail, regular road traffic, pedestrian traffic, all built onto this 100-and-something-year-old bridge. And they have like weird data points, like they're tracking analytics off of it,
cool.
which they could do considering it's at the point where a lot of the steel, or iron, I should say, needs replaced. It's at end of life. But that's a whole different story for another day.
So if you're in Portland, watch out.
Yeah. Watch out for that bridge. It's beautiful, but also it's
may die.
That time. Yeah, you may die. Cool. Yeah. So real into data nerd stuff. So AppStax. You mentioned AppStax. I definitely wanted to talk to you more about that. And I'm going to lead you in with one of the things that I've been working on. So I write a bunch of languages because you have to. Or at least I feel like you have to. One of the things that I started doing was writing a schema migration tool in C# specifically for Apache Cassandra and DataStax Enterprise with the intent to go past just key spaces and tables and move into the graph realm, et cetera, and like cover all the bases of anything that you would need to set up schema-wise, or even maybe some of the queues or whatever, like in Kafka or something like that. Wow. And right now I've only gotten so far, but making progress. I've been streaming a lot of it on Twitch, on our DataStax Devs channel. And then I started looking at AppStax too. Also saw the preview video before the preview video of the preview video of it, and it's like, this is going to be freaking awesome.
The preview of the preview.
That's right. The preview of the preview. They just keep getting better and better. Like from the cartoon character stick figure to like the next one.
Yeah. We're going to do some crazy CGI for the next one.
Oh, yeah. Get into the high budget dollar stuff. You know? Spend like $50.
Millions of dollars. Yeah.
Millions of dollars. So my big question there is, and Jeff Carpenter is on too. So he says, what's up?
Hey, Jeff.
My big question is what schema migration stuff is AppStax going to be doing?
Oh, okay. From a schema. So
yeah.
to back up, so with AppStax, we're trying to do this thing where instead of you basically figuring out like, okay, I need to have the following object model in my code, or I have the following like logical data model,
right.
And then you working towards the physical data model that captures your logical data model in a way that is quickly accessible, and if you're doing relational, that follows certain normal forms. If you're doing Cassandra, that is perfectly denormalized to do your queries. Like basically, There's a lot of work that people do to go from logical data model to physical data model, right? And that translation is often highly non-obvious. And then the problem is if your logical data model evolves, so you have additional use case requirements, the way that you want to solve the problem changes, then you have to update the physical data model according to that new logical data model, but you also have to then sort of do the schema migration from the old model. Yeah. And that there's just so much pain involved in this because you often these are highly non-trivial mappings, and so you have to like figure this out on a sort of case-by-case basis. And with AppStax, what we're saying is actually we're going to do that mapping from logical data model to physical data model. We're going to take care of that entirely. So any denormalizations, anything that needs to happen in order to make your physical data model perform, we will do for you.
Okay.
And we will hide that behind an API. So instead of telling you, okay, here's a bunch of tables in Cassandra, and now you can query them individually to get the data that you want, and here's the materialized views you need to maintain, and here are the denormalizations you need to maintain on the right side, and all that complexity, we're saying all of that is hidden behind an API, and you just get the data back. So that gives us then the flexibility to do the mapping
Right.
on the back end. And if you need to then change anything, we can also remap it on the schema migration side. So you don't actually have to worry about updates, and the API contract is the one that you just defined. So you can easily migrate your application to that new API.
Okay. So that's kind of what I got from the preview. The preview videos. Yeah. And I haven't played with it a whole lot yet. Like I've dorked around a little bit. Matter of fact, at Accelerate, that was when I was kind of looking at it a little bit more and stuff. But the being technically familiar with needing to do a lot of the things that it is going to do, it makes me very curious about like what's the decisioning process? Like what's the business rules it's following? How's it determining? Like is it doing? Is it reverse engineering of things? Like what's the process there?
Yeah, so that's a really good question. I think part of that we have figured out. Part of that we're in the process of learning now that we're working with customers and really getting to like actual use case implementations.
Yeah.
It's actually a mixture of things. So there's a mixture of we employ some best practice rules. So things that the developer advocate that you would find up in an academy course, right, where people talk about like here's how you pick your clustering keys and based on your access pattern, here's how you do this, here's how you do that. So we encode those pretty straightforward rules. But the other thing we're doing also, we are trying to infer from your queries and your logical data model what the most likely evolution paths are that you're taking. Okay. And so that's something that maybe to give a simple example, let's say you have customers and orders, let's say, right? Those are the two logical entities. So this is going to be a highly trivial example, but I hope it gets the point across. And so you have like one customer can have one or multiple orders associated with it. And then you're saying, okay, the query that I want to have answered is for a particular customer, I want to see their most 10 recent orders, right? That's a query I'm doing. So now if you approach this from a purely Cassandra perspective, you say, okay, I need one table that has the partition key customer and has a clustering key on order timestamp and plus order ID, and so I can quickly do that top K query against that partition. Now, we know from the data model that likely you will also at some point evolve the query access patterns to ask questions like, give me a particular order for an order ID, right? Because we know that is the unique ID for the order. So it seems highly likely that you will in the future evolve your use case there. So we make provisions ahead of time to make that transition less painful than it would be now, where you would essentially have to like decompose those two tables that you have denormalized into each other. Right. And so there's a couple of rules like that, or rather, they're not really rules we use in an optimization program to kind of figure out like what is the maximum amount of denormalization that we can afford for this while still being able to meet your SLAs. Yeah.
So there's a question for you already. Sweet. We're going to get back to that one in just a second because I have another question. Okay. So in denormalizing all the tables, definitely sounds like it's managing the schema from that point of view. What's going on with the data if there's already existing data? Is it going to deduplicate or duplicate data as needed to make sure that it's available in all the places?
Yeah, exactly. That's like because we know what the mapping is. We know that if you like, for instance, in some cases, it's pretty obvious. Sometimes it's like, oh, we need to have an additional materialized view on this because we have a different access pattern on that particular table, right? And then you need to either install or uninstall a materialized view. Right. So those are sort of the trivial ones. But then there's the more complex ones where we know, oh, we need to like actually design a whole new table, in which case we need to run a Spark job that takes two existing tables, merges them together, and builds you the new one. And we kind of have an eye towards that, and that's we basically, for AppStax, we invented what we call, like, it's kind of a joke, like, how like in database systems we have normal forms, right? Like, and there's the various normal forms.
First, second, third,
and fourth,
into the mythical fourth and fifth. Yeah,
exactly. There's a 27th probably somewhere hidden in Cod's grave.
Super form, no data.
It's just inspiration,
right?
It's like, yeah, exactly. It's the nirvana. It's the 27th normal form. But so we invented. I mean, this is tongue in cheek. We invented the abnormal form for AppStax by basically saying, like, in most cases, the normal form gives you it's easy for the developer to use because you know that you're not replicating data in any place, and then the database figures out how to stitch it together. The problem with that is that in most cases that becomes so inefficient that the developer is forced to then denormalize the data anyways, right? So it's for most high scale applications, normal forms are a bit of a joke because you're like, well, that would be nice if we could do it, but we can't, so we have to then denormalize it, and they don't provide much guidance. So what we're saying is, you just give us a logical data model, and we figure out what the least costly abnormal form is that we can maintain for you.
Yeah.
Right. So it's kind of taking the whole notion of what databases are and spinning it around and saying you don't actually care about normal forms because those only exist from a sort of a DBA perspective. What you care about is your actual logical data model and what you want to do with it.
Right.
And then all that physical stuff we should be taking care of, and we should actually maintain it in a way that is best for the machine to process it, not optimized for some human that needs to go into the tables.
That makes sense. Yeah, my next question was going to be, how are you queuing jobs and stuff? So Spark kind of answers that.
Oh, yeah. So there's a lot of stuff there, and like some of it, one of the things, like AppStax as it is right now, it's like a very early stage product, right? So there's like some things that we have in the EAP that we're currently doing with customers, and then there's some other features like the Spark integration that are like more like prototype stage right now for like higher forms of denormalization that we're maintaining. But that's basically the underlying idea is to get to that.
I like it. I'm really looking forward to playing with it more. I'm looking forward to my own Twitch session.
Just with AppStax.
Yeah. Lina Droid asked.
What's the name?
Lina Droid.
Lina Droid. Cool.
Yeah. Do you know if DataStax is working on a Cassandra operator for Kubernetes? Kind of what Confluent has recently released for Kafka. Yes, we are. I don't know how public that is, though. I just said it, though. People have talked about it.
The good thing is you said it, so you're going to get fired on me, so that's nice.
Shit.
No,
nice knowing you, man.
Yeah. You can invite me anytime. I think it's probably public. I don't actually know. Yeah, when is the ETA? That's a good question. Honestly,
Tuesday.
You know the time though?
I don't have any idea what the schedule is.
I don't know what the operator
because I know. Well, right now there's.
I don't know when it's going to be. I know that we're working on it. We have a team working on it.
Yeah. And it's supposed to be okay to talk about. I've actually asked, but then of course I don't know if I've ever asked the right people. But yeah, we are working on it. I lose track of this and that and whatever, the specific pedantic details. But there's also the existing ones in market, of course, that people have hacked together. But we are creating one that will be fully supported and all of that good jazz.
Yeah, I think that's the thing. Like they obviously exist already, and we're using them internally. I think the part that we're trying to figure out is when we can release something where we can fully have full support behind it. Our support team being completely trained to make sure we can maintain that stuff in production.
I would assume that it probably revolves somewhere around the team that is building it. Jeff mentioned too. Yeah, it was mentioned at Accelerate. I think it was like kind of a blurb within the big keynote of all the other awesome things that were getting released. But I get the notion that the team building it, once they dog food it thoroughly and are very happy with it themselves, it'll probably migrate into the open source realm of existence and other things like that, and be usable by others. Confluent team optimized for Azure. Oh, context. Lina Droid's actually that's my wife, and she works at Microsoft.
Gotcha.
She works on all that good stuff. So now the world knows.
And her name is Lina, by chance?
Lina, yeah. So Lina Droid, yeah. Which I always thought for the longest time it was Lin Android, like a person that was really into Android, but that's not what her nick is. So.
Yeah, glad did you clarify that over dinner sometime?
Yeah, it's just, why are you so into Android? You don't talk about Android at all.
It's misleading.
Even had an iPhone at the time.
Jeez.
So super confusing. But yeah, so that's when the operator's coming out. But yeah, so you're primarily working on AppStax though, right? That's your
fully, yeah.
primary thing.
I don't know much. I mean, I obviously know what's going on in the company, but not entirely like to the deadline level of all these projects that are ongoing.
Yeah, it's probably best to not know the deadline level of things to some degree. At least I feel that way. Oops, hit my mic. Bang, thud. And the reason I say that is because usually I feel like deadlines create an unnecessary stress most of the time that then just make deadlines get pushed. So if you just work on it and you get it solid and you're like, hey, this is ready to go, then someone can say, hey, let's release it. And then you go, well, it's the 28th, so boom, it's released.
Right.
You kind of ship as things solidify instead of just setting arbitrary deadlines.
I think this is a really interesting question from an engineering management perspective, because I do find that most deadlines are somewhat arbitrary, and then they don't mean anything, and then they get pushed out and such. But I also find that if you have no deadline, like what ends up happening is that oftentimes the scope expands, right? Because inadvertently people are like,
get entirely derailed.
oh, we have so much time. Let's think about this and that corner case, and all of a sudden you're like, this little thing that you were building turned balloons into this crazy. We're going to solve every problem.
Oh, yeah.
And world peace.
Yeah. And let's have a barbecue, like right now. Then we'll get back to it.
And then it doesn't get done. So it's like it's a fine balance. But on the other hand, if you're constantly like deadline, you set unrealistic deadline, then you just lose the trust of the team. You lose the trust of everybody, and people are just like, there's this guy who runs around with arbitrary deadlines, but nobody holds him.
Deadline guy.
Yeah, nobody holds him accountable to it.
Nobody pays attention to it. Just ignore him.
Yeah, like we call that is just psychological warfare, where you're just like you're just trying to stress people out so they work more, but it doesn't actually mean it. There's no tie to actual like real world things. So I think it's tricky to find a balance, and so I'm trying to give up on this notion of there's a deadline, but rather have this is the whole agile thing, right? Like rather have like very concrete specific milestones where you can deliver something that you can actually like evaluate and say like, have we met this goal or not? Have we learned something? Instead of saying we have to ship something on December 20th.
Right.
Because then it's like, what does that mean?
I found through years of contract consulting, freelancing, whatever you want to call it, one of the thing I always like to do is chunk it down to reasonable sizes of like things that are actually tangibly deliverable. Like I say, I'm going to create a coffee dictionary, right? Boom.
Oh, that's yours?
I didn't make it. I'm just saying.
Oh.
Like, I'm going to make one. So I went and bought this. I delegated the production.
I thought you'd actually written this. I was like, I wish. That'd
be pretty
so
awesome.
Funny.
That would be a good accomplishment. It's a nice little
it's
coffee dictionary.
A little like plug.
Exactly like
Adrian's book.
Now I really do need to create one. Just out of like promise. But yeah, so like having a solid deliverable that can actually be put into someone's hands, or put into someone's computer and let them work on it or whatever. Like having something that tangibly can be shipped on a pretty regular basis and then have it mutated or changed or whatever. That's the best way to deliver stuff. Like if things get a little too big, or like the anti-pattern BDUF, big design up front syndrome takes effect, where you're just designing all the time effectively, and then you like ship it off to get it built. It won't get built. It'll end up, everything will get all messed up. But like the smaller pieces, like here's a thing. Yes, no, like okay, we can work with it, keep going with it, and then just work off of that and build up off of it. Seems to work just so much better because you're always getting feedback then too, and that always seems like the key. If you just set the arbitrary deadlines and arbitrary whatever, you kind of start banging away at it, and then you get stressed because you're like, well, I don't know what the feedback is. No one's seen it yet. Like you hear words like that, and it's just
exactly. Then you never want to release it.
Right. It's like, I don't know if this is the right thing, and then you ship it, and they're like, I thought I was going to get a first-person shooter, not like a spreadsheet. What the hell? Why'd you make a spreadsheet? Well, we needed a spreadsheet to track the project to make the first-person shooter. Right. We just have the spreadsheet so far. Well, that didn't do anybody any good. So.
No, that's so true. And that's like one of the things that I think one of the challenges migrating out of academia, like in academia, a lot of the research project, like a lot of the software development is like, can we actually develop this thing, right? Like, can we actually develop, in my case, a graph database index structure that actually works efficiently?
Yeah. Chris says, expected FPS, got Jira. Yeah. What a letdown. That's not what I was expecting.
Like when you try to do that migration, like there's a point where like the hard part is the engineering, the actual building of stuff. But now most of the actual challenges are building stuff that people can use.
Right.
And the only way you can find that out is if you actually give it to people to use. And so I think that's where people fail a lot. Is like no, it's like make it perfect. Let's really build it. And you spend like a year building something. Then you go out and be like, here's the thing, and everybody's like, what is this supposed to solve?
Yeah, it's like we forgot what we asked for too. Yeah, that's one of the things that so I'll tell you another element of my Schema Migrator that I started writing. So the first thing was that I sat down. I'm like, all right, I'm going to do some C# stuff with Apache Cassandra and DataStax Enterprise. What do I build? Don't know. Had no idea what to build. So I was like, oh, well, I need to put a schema in the thing. So I'll start writing a Schema Migrator. So like second or third episode, I decided to start writing this. I've been writing it. And then a friend of mine I used to work with said, hey, we've been curious about doing Schema Migration because we're not really sure how we're going to do it yet. And I'm like, ooh, you're in luck. I'm building a Schema Migration tool for this specific stuff. So I've been working on that, and they've been looking at their problem space and trying to figure it out, and we're starting to we're going to sync up and kind of get on the same page and look at their specific needs around it. Because like one of the things that I've run into myself, okay, there's already Schema Migration tools out there for basically the columnar store, distributed database nature of Apache Cassandra, core database, DataStax enterprise functionality. You can get that in a number of tools. Like there's Go Migrate, super awesome, and it works against like every freaking RDBMS there is. So like that part, the part that you can kind of mimic what Schema Migration has traditionally been done for relational databases, you can use that now. But it's those other parts in DSE where I was kind of like, wait, there's so much more to it that you want to be able to like track against and figure out and have your schema mutate over time with whatever you're building onto it. And right now, I assume a lot of people probably are handwriting this stuff or handwriting whatever schema they're building out or whatnot. And I was like, I'll build a tool for this. But as I've done that and started to look more at like, well, how would I say the graph store is going to look like this, and here's a schema for it with the tool, right? Like right now, you don't just go in there with CQL and do it. You do it. You have to figure out your Gremlin queries and all this other stuff. So it's gotten, let's say, more expansive. Maybe the scope has increased, but it's very interesting in that getting feedback. Oh, that's a good question too. But it's very interesting in that regard. And I'm kind of, I have to admit, a little part of me says, I hope AppStax just completely replaces the need for 80% of what I was thinking I was going to write. But it's still a good thing to build with C#. Shows you how to work with C# against all that stuff. Use the driver set, all that.
Yeah, no.
So good sample project, right? So Jeff was saying, what are your recommendations for getting feedback on a new product?
Ooh, that's a good one.
Yeah.
The really, really, really hard piece is that most people are too nice, right? And that is, I mean,
get me to look at it. We can talk about this offline. Just turn the cameras off and I'll talk to you about it.
Just hear like beating sounds in the background.
Yeah.
Like my arm, like.
Yeah.
No, I mean, no. Being serious, like I think it's part of human nature is to want to be nice to the people that are around us, and I think that's that's a very, very great trait that a lot of people have in our industry. And so when you go to somebody with feedback and be like, "Hey, I built this thing. What do you think?" Like their intuition, exactly. It's like it's my baby, like and you like hand it to them, like then obviously their intuition is to say something positive about it, and to point out the positive things, and that is usually the least useful for you, right?
Yeah.
And so you want to make sure that you preface it with like, hey, we really want your honest feedback and things like that. And a lot of people, then resort to more positive feedback. But it's still highly challenging to find people that, on the one hand, really commit to understanding what you're doing there, right? And not just look at it surface level and be like, oh yeah, that looks really cool. Like, like the Trello kind of thing. It's like, oh yeah, like it handles data layer API. Like that sounds great. Let's do it. But not really look at the nitty gritties of like, what is it actually doing? How does it work? And what is the value that it delivers? And then on the other hand, like then giving you the honest feedback of saying, look, honestly, I don't get it, or like I don't know
Right.
what you're trying to do here. So the best that we have found is that a lot of this kind of qualitative feedback doesn't really work. And you want to make sure that you talk to people in a way that you can actually sort of get some more objective data. So one thing that we do is we look at, for instance, for AppStax, right? Because it's a SaaS product, so you can use it online. We look at, hey, can you accomplish this task for us? And we look at how much they struggle accomplishing this task, or
Right.
like what the task completion time is, right? Which is a more objective measure. So they might say, yeah, this is super intuitive. I really love the UI. And then we ask them, hey, can you please add a new entity with a relationship to it? And they like struggle finding where they need to go, and then you really see what is happening, right? And you get like real tangible feedback. So that is more useful. And then obviously trying to actually work on real problems and getting people to commit, because that's the ultimate measure of feedback, is like somebody willing to say, hey, this looks interesting enough that I'm willing to actually work with this and trying to get something done.
Right.
And that's when you get like the real honest feedback, when people put something on the line to like make it happen. But it's challenging. I think it's one of the hardest things in building software, is getting good honest feedback and finding a means for doing that without a whole lot of overhead, right? Like,
Yeah.
because most systems are very deeply thought and very highly susceptible to bias. Like I basically spend maybe like a quick little plug. I read the book Lean Customer Development by Cindy Olivares, and it was super enlightening, because a lot of, like, when you read the book and you've ever done a user interview or anything, or a feedback session, right? You just read the book and you're like, yep, did that wrong, did that wrong, did that wrong, did that wrong. Cool,
Yep.
I should have never done it in the first place.
Right.
Because it is just, she points out so many things about how you frame questions, right? If you're like, hey, do you like it? Like, what are you going to say to that question? Yes.
Yeah.
Every single time. So you need to find very different ways of asking the questions, very different ways of presenting it to somebody, so you can get some more honest feedback. And I think that can be very helpful. I would encourage anybody, that book, and the Mom's Test. I forget what's I think it's called the Mom's Test. That's another really great book that goes into detail as to how you can collect actionable feedback. And I would say it is highly non-intuitive, unintuitive, because it is so, like, so many ways that we have adapted for communication that is aimed at interpersonal exchange and bonding, right? Like, it's totally the wrong thing to do when you're trying to get honest feedback, right? Like, so most of our intuitions for how we should interact with people do not apply for product feedback. And so, like, being able to undo this, like, you either work with somebody who's been doing this their entire career, but if you don't have that luxury, meaning you don't work for a large company and you have to kind of do it yourself or wing it a little bit, then you definitely need to do a ton of research to make sure you don't basically just fall into every little trap that is along the way and gather data that is basically meaningless.
Yeah, it is. I was oblivious largely. Before I blab though, I'm going to say what Lina said. She said, I found it's useful to try to narrow down what parts of the product you're curious to get feedback on most, and get them to spend a limited amount of time trying it out, e.g. like just 30 minutes. People tend to be more open when they know you don't have unrealistic expectations about the feedback. I can definitely see that too. Yeah, so
agreed.
I was somewhat oblivious to feedback, because a lot of the apps I built early days were kind of enterprisey CRUD apps where, a portfolio manager, someone with domain expertise, would come to me and say, like, I need XYZ, I need to be able to track this, and I have 89,000 SKUs on something for oil disbursement management, blah, 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 some fancy thing. I'm like, okay, that's a fancy spreadsheet with an interface. That's what you want. Cool, I'll build that for you. Boom, I'd build it. They'd come look at it, and they'd say, well, I want these extra few features. I'd build that, and then they'd probably just go away. And they're like, that tool did enough for them that it streamlined a whole bunch of tedious crap for them.
Right.
But it's very much like that type of person is basically just another engineer working with an engineer that makes the thing on the screen, right? So it's two people not really good at making a user interface. So, like, enough to get it done is enough.
Right.
But then one day I was being an engineer at 3 o'clock in the morning. And I noticed that because I was mostly speaking with Europeans on the Twitters. And I decided I was going to go through this whole thing with cloud provider and this other thing and put a framework on my machine and try to get all this stuff to work. They had been talking about, like, this new thing was all whiz-bangy, fancy, super easy. And I started. And it wasn't easy. So it turned into this huge Twitter thread where I think I had 200 tweets in it.
Wow.
And then there was like another 1,000 around that where they're like, "Ooh, did you try this or this? Did you see this as complicated or whatever? Like, what was your perception here?" And I'm just giving them feedback the whole time. That's what I was doing. I was just being super blunt right out there on the Twitters, like you do. And I went through all this, and then I got to the end, and I was like, I basically haven't really accomplished that much. This was not simple by any means, and I know, like, I'm not Mr. Super Developer, but I know what I'm doing.
Right.
It's not like I'm trying things that are completely not intuitive because I know, well, they probably did this. Sometimes it works, sometimes it wouldn't. And got to the end of it, and then afterwards somebody contacted me and said, "Hey, do you think you'd come in and do like a full application evaluation of this framework and all the stuff trying to use it on this cloud provider?" And at the time I was like, "Well, no, I'm a bit busy. I was just doing that for fun, and I didn't feel like sleeping, so I did that." But they're like,
classic,
right? And what they said was, "You know how hard it is to get like direct, just blunt feedback on stuff? Like that's what you did. You just puked out all this great feedback. We loved it." I was like, "Oh, I'm sorry, that's not what I do at all." That was just me fiddling around." They're like, "Well, if you ever feel like having another one, let us know beforehand, and we'll make sure the whole team's watching your tweet stream."
That's so funny.
It hit me also at that moment. I'm like, wow, feedback is hard. Like if you
Absolutely,
really
because most people don't have the time to like write down what they think. Like they use a product, they struggle, they leave. That's how that's how it works. And then you might be able to see them. Yeah, right. And then you see them. Oh, they dropped, and you never know why. And that's the hardest thing in the world, right? To figure out. And I think we're starting to think differently about software engineering, where it used to be, you get the requirements, like you have a domain expert that tells you, I need exactly this, boom, done, do it. And then you translate it into specs, and you do the work about like what needs to be the database schema, la 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 la. You build the whole thing, deliver it, they test whether or not it's what they asked for, and if yes, you get paid, if no, you don't. Or you have to go back and make changes. And I think we're changing that to, in particular for new software, changing it to how can we measure the entire user journey through this product, with an understanding towards what the user is trying to accomplish at every step, hand-holding them through that, and seeing when they drop off, trying to find out what could be the possible causes for this, and then experimenting with them and seeing what the funnel rates are. So it's just a different understanding of what software is, and to Lina's point, and really understanding like where are new components. Like if you're building like an e-commerce platform, like you don't have to reinvent the checkout flow, right? We have done that a million times, and you can just copy somebody that feel like is what you need to do. Mm-hmm. But if you have if you have a new kind of software, a new SaaS application where you're trying to reinvent the spreadsheet, there's probably only 50 million startups that are doing that. But if you're one of those, then you really want to pay very close attention to what exactly is the user flow through this product, to understand what is happening at every step, so you're not so you have that objectively quantifiable user feedback. And that's one of the hardest things, I would say, making that possible.
I can imagine with spreadsheets too, it's even more so, because like the Excel universe has shaped so much of the existing knowledge about how we use what exists. So then if you try to fix that, you have to take into account that what's partially shaped already, and it may be shaped incorrectly for doing it well. And that's like a big difficulty. I mean, hell, that's the same thing as like somebody gets into the relational database world the first time and they come straight from spreadsheets, and it's like all they do, what do? They take the spreadsheet and they go right into a table. That's where the spreadsheet goes. So you've
yeah, absolutely. Yeah, then you're trying to.
Well, here we go. We got the spreadsheet in here. We put 20 million rows in here now. We're not limited to 1 million anymore. Just throw it all in there.
And it's so funny because a good example, like what we're working on is, relational databases are the de facto database for pretty much all applications that are being developed, right? Like that's like it's like 90% of the market. If you go to DB engines and you sum up the relational, like everything else basically doesn't matter.
Top 7 of the top 10 or something.
Right, exactly, and by a large margin too, right? If you look at like MySQL up top and SQLite and all those. So that is, and everybody who goes through a CS, degree of some sorts, or even like a bootcamp or whatever have you, they will touch a relational database in some shape or form, right?
Hope so.
Yeah, if you're a curriculum developer for CS, you should definitely put that in there.
Yeah.
But that's like, when when you learn databases, you learn relational, and that is the only thing you know, and that's how your worldview gets shaped about what database is.
Right.
And so you start to think in those terms, and it's really funny when you try to do something slightly differently, like we're trying to do with AppStax, something that on the surface would be so much simpler, where we tell people, hey, just give us effectively your object model, right? Which most people start with, right? Like, is your object model. Just give us your object model. We'll figure out the rest for you. People struggle with that because they're like, but where's my foreign key? Like, where do I put my foreign key in here?
Yeah.
And we say, no, you don't. You just say there's a relationship from X to Y, and we figure out the foreign keys and the consistencies and the indices and all that sort of stuff. But people, are so used to that they find that missing. And so now we find ourselves building the AppStax user interface in a way that we basically want to give the relational person the assurance that this is all kosher. Right? Like there's foreign keys, and we're taking care of all of that. Because that's what people expect. So it shapes people's understanding of how the world works. And then if you try to do something too radically novel, then people are like, I don't know what to do with that. So even though it could be much, much simpler.
I feel like a lot of things could be much more simpler. I feel like we make it complex sometimes before we make it simple. Like we have to overcomplicate things, and then we go, hey, now it's too complicated. Let's notch it back a level and rethink what we actually did.
Yeah, and
at least that's my hunch. I could be wrong.
Sometimes it's like, part of that is also that sometimes, with software, the interesting thing that is happening is like it now becomes actually viable to carve out many more sub areas, right? Like if you go back to like the end of the 1980s, right? Like it makes sense why spreadsheets are the way they are, because people were basically just trying to get the ledger into the computer and make it something that people could handle within the very confined screen state. And
it makes complete sense when you do that. You're like, oh yeah, it's the ledger.
Exactly, and you kind of like copy it over, and then that lived for a long time. And now we're seeing how like people are carving off things that people would have used, like you have Trello, which people would have used spreadsheets for in the past, but now we have like Trello and Jira and all these other tools that used to be spreadsheets, but then we built custom things for them.
Jeff says, I'm looking for where to set the FK. Am I the target audience? Me and him were just talking about Trello too. It's funny you bring it up, because it's like there's so many of these, I don't know if you call them productivity apps, basically glorified task list, right? And they like, some of them have correlations, like you can put a team into it. Some of them just are more focused around like the swim lanes. Like Trello is mostly like swim lane, swim lane, swim lane. Everything is in a swim lane, and then the entire existence of everything is focused around that. Which, sometimes it works, sometimes it doesn't. And then you have other things that are like team focused around documents, but the document is the focused, and the notion of the document isn't even really like a document. It's like a thing of text, i.e. Google Docs, for example. Like the whole idea that they even have the what do they call the file share part of that?
Like Google Drive?
Yeah, Google Drive. And it's sort of organized like files, folders, etc. But they even got rid of the files and folders part of it on your local machine, and they try to make it more like these are just entity things, right? And get rid of the whole file and format thing. And there's sort of a team concept. But then there's the things that are also like super, super team concept, like Asana. But the document elements are still there. Like you can just drop document elements within the task list. But all those things, it's kind of like, well, you really have to sit back and figure out what it is you're trying to organize, and then determine like, well, which tool, what the hell is going to actually work? I feel like I just dump everything into one thing, and then it gets up to like 60% of what I want. I'm like, all right, that's good enough. I'll write everything else on paper or something.
Yeah. I mean, it's so funny, right? Like considering how many people are working on the productivity software, that it's still essentially a mess. Like it's still, you still can't find the stuff you need to find, and you still have so much trouble. Like when you work with the team to get everybody on the same page, and so many people have been working on this problem that, there's something almost intractable about it. Where like every time somebody sets out, like the Facebook co-founder with Asana, and like yes, there's another one, but you look at it and you're like, yeah, that's great, and this from this angle, but it doesn't solve that, and you're back to like 25 different spreadsheets tracking something.
I feel like the root of the problem here is a very similar root of the problem. I was talking to some urban planners recently, and they're like, what the problem is? We could design perfect city for people, if we didn't have the damn people.
If you had the perfect people.
We could just build the city, and it would just work. But we put people in it, and they mess it up because they all want to use it different.
It's true.
And I'm like, hey, it sounds real familiar. And I think that's kind of the root of that. It's like, you know, we're building all this stuff for people, but all the people want to use it differently. You know, we all kind of interact with things just different enough where it makes it next to impossible to build like the thing, right? But
no, that's true. I mean, people are at the root of all problems, really.
Of course, yeah. We're
like
complicated,
a deeply philosophical
frustrating little, get metaphysical and everything in a minute.
Exactly.
If I could just optimize my workflow, I could finally get something done. Exactly.
Exactly.
I got a task list manager to sell you.
I recently read that was great. Lacefield, a colleague on the PM team, shared an article from somebody where somebody like went like just crazy on optimizing their productivity cycle for the day.
Yeah.
They like planned out like a crazy productivity, like work 25 minutes, then 5-minute break, then 20 minutes, then 10-minute break, then like 25, 5, 10, 2 hours, like
and they had
all
like this
broken
iteration
down.
broken
It was like it was the craziest Pomodoro thingy-majiggy, and you look at that and you're like, crazy. Like this guy probably spends half his day thinking about what productivity method to use for the rest of the day.
I think like,
at which point that becomes the actual work.
Yeah. I feel like it's too dependent on outside air, like just random stuff. Like I feel like the air quality.
Oh.
Well, last summer it was like the end of the universe. Yeah. So I feel like depending on so many things, like if I created a schedule like that, it would be gone in 5 minutes. Like it would be useless because something would get screwed up.
Yeah.
You know, or heaven forbid somebody calls me on my cell phone and I'm like, oh my God, it rang. What do I do? Oh, I pick it up. Shit.
Yeah, that's the other thing. You know, it's like it's once you're on a schedule like that, you'd be like, okay, I'm in my 25-minute work period, but like somebody's at the door. Like, what do I do? Like, don't open the door for 25 minutes?
Right. I guess not. You just hang a sign up there and say, yo, I'm in my period, my range here of this stuff. You got to wait 5.
Just got to run down there and change it real quick. No, I mean, that's the truth. And if you're working in a team, that obviously that doesn't work because people ping you and like, so yep. Productivity is, I think particularly for engineers is like a hard topic. I think there was like a particular part in my engineering life where I would just freak out so much about my productivity. I'd be like, every night I'd be like, where did I lose like the 1-2% and could have done that and this and that here and there more efficiently and whatnot. And then you freak out so much about it that you spend like so much freak out time that you become less productive.
Right.
So at some point you just got to be like, just trust yourself, trust that you're getting the work done. And quite honestly, there's some days where I work, I do meetings, whatever. Then I have like this work thing that I want to do, and I start doing it, and I realize no, it's not going to happen today. Like my brain is just fried.
Yep.
And then you just drink a cool beverage and call it quits.
I like the 25-5 too, Jeff. That seems to work pretty good for me. But sometimes like Twitch streams don't work too good. But I do have I have a clip that comes up and says I'm back in 5 minutes.
Oh, okay.
So that's pretty cool. Then I just get up and walk away from the computer. So that works out. But
yeah, if you have an audience, obviously you can't be like
spend about
so flexible.
2 hours building that 5 minutes video. That's how video works though. Like every minute you see of entertaining video is somewhere between like 30 minutes and 40 days of construction for that 1 minute. It's such a
what happens in those 5 minutes?
It just says that I'll be back in 5 minutes. It has like a countdown. It's got some like other graphics and stuff that pop up.
Oh, okay.
That just so it's not super boring. Like there's code in the background or something like that. Happens.
Sweet.
I think it's like I got one where it's
it
shows a Terraform executing and applying an infrastructure against something. And it's just back there like happening.
Oh,
so
nice.
somebody logs in, they're like, oh, he's doing something. And then it says, be back in 5 minutes. And they're like, oh, he's not really doing nothing. This thing is just running.
Just faking it.
Right, exactly. So that works out.
Yeah,
pretty
the
good.
whole I'm just in awe with this whole Twitch universe here.
Yeah, it's pretty cool. What are some of the? We got another question, and I just blopped it off the screen. What are some of the challenging, confusing, surprising technical issues, bugs, or other things you've encountered while working with Cassandra?
With Cassandra, the bugs. What were all the things? Challenging, confusing, surprising, technical issues, bugs.
Yeah.
So I started working with Apache Cassandra at version 0.5.
There you go. Now it's big.
Wow, exactly. For my old eyes.
I mean, I do
Yeah.
have this set to max res. It's not like the friendly resolution, so
Gotcha.
you're doing pretty good. Those brain explosion moments.
Yeah, what was it? Like Cassandra 05 was definitely rough, right? So those were like the thrift
Well, you
days.
said 05?
05.
Oh, yeah, that was.
That was crazy rough. Like,
When was that? Like 2009?
yeah, 8, 9, yeah, early.
Yeah.
Yeah, I think I started working. Yeah, 2009, I think was it. And there were like some just crazy bugs, right? Where like data was lost and like
Just
SS table corruption, like that sort
Yeah.
of fun stuff. There were some really serious things back in the day, but like working with Thrift and the whole binary protocol and like serializing everything into like byte buffers and moving back and forth bytes and bits and things like that. That was a hell of fun. And making sure the byte order was right so that the comparator, like the clustering keys would work for your specific like access order. That was, yeah, I don't miss those days. I think CQL is definitely a good step in the right direction there. Although it was kind of like we did some fun stuff in particular for graph databases too. Like we did a lot of like graph compression techniques, and then you could like compress the data into a byte buffer and just throw it in there.
Okay.
And if you had like a compression algorithm that was order preserving, you could actually make it a clustering, like what is now a clustering key. And all the terminology changed. I remember like back in the day, it used to be all called something different. So that was fun, and definitely very very buggy days. I think the hardest part with Cassandra after that is really understanding eventual consistency. That is. And that's a lot of the work we're doing right now is to take some of that complexity out of the system, because I think for a lot of people that can be just so overwhelming to think about. And definitely an area where I think we still need to do a lot of the theoretical advances in terms of how we think about that system.
Yeah.
Like I like, for instance, what Cosmos DB has done with their their session consistency level.
Oh yeah.
Right, where you say, hey, you can like basically within a certain session you can read your own writes, but like you don't really have control over what's happened outside your session. And usually that's enough for people to logically reason about what's happening with their data, right? Because you just want to make sure that for a particular user using your software, that the data looks consistent to them. So if they update something and they read it back, then their update is read back to them. Whereas if you work at the lowest consistency level, then you can be in a funny situation where you write something, and that write doesn't, get percolated, and somehow the driver reconnects to a different machine or whatever. You do another read at CL1,
right?
And the data isn't there, and the customer's like, "Whoa, the data was lost," and then they enter it again, and then they like have duplicates, and those kinds of things can be highly confusing. And so I think we're still, that's still a road to be traveled. I think for database systems in general, it's like, what are the right consistency semantics that we can give people so that you can be effective with databases without going sort of nuclear and having like serializability, which just obviously doesn't scale and is so expensive to implement.
Yeah, I'm sitting here thinking so many things, but I don't. Yeah, I'm not going to bring them up right now. That'll be another hour and a half stream.
That was the teaser.
Yeah. So on that note, I'm going to say fairly well to everybody. Thanks for coming and joining us. It's been awesome.
Of course.
And next time we'll argue about vector clocks or something. So stay tuned, hit follow or subscribe, and you'll get all the details. Not really going to argue about vector clocks, but you never really know. So anyway, on that note, everybody have fun, cheerio, and enjoy your Wednesday.
It's a Wednesday.
Enjoy your Wednesday.